So thank you for joining, everybody. My name is James Christ. I'm one of the senior application engineers at EnginSoft. So I support some of our RecurDyn customers as well as a few of the other products we carry. So high-level overview of what we'll be going over today. I'll do a brief introduction about who EnginSoft is for the folks who are new on the line. Then I'll do a brief introduction on RecurDyn. Again, I know we have quite a few existing customers, so that'll be a little redundant, but for all the new folks on the phone, it'll be good to have a high-level intro. And then we'll jump into the meat of today's presentation, talking about fatigue and durability. I want to do quite a bit of the essential concepts, kind of going over the background theory before we jump into a brief live demo of the software. And then we'll wrap up with a Q&A session. So when you have repeated loading, the static yield strength is kind of a useless metric. We don't care if it fails on the first cycle, we care if it fails on the millionth cycle. So we need some way of sort of quantifying that. We do that through this fatigue analysis or durability analysis. They can really be used interchangeably. And we think about things in terms of fatigue life. So how many cycles can something go through before it's going to fail? And to sort of formalize that, we have this SN curve. We'll come to in a second. And we can use this type of analysis to look at not just very simple sine wave repeating loads, but irregularly repeating loads. At this point. So now we'll go more into kind of what you would be doing in the software to perform this analysis, right? We've talked about the background theory is, but at the end of the day, you need to give your boss a number on how long this thing is going to last. So next we'll kind of give a high-level overview of what the procedure is. So you'll run some flexible body analysis. Glossing over that part today, but I think we've done webinars in the past talking about falling. We're going to, so once we have the stress strain history data, then we can do this. Everything else is a post-processing step. So that's one thing that's kind of important to note. For the purposes of durability fatigue analysis, you just have to have results data. But everything beyond that is post-processing. So you don't have to know ahead of time that you're doing a fatigue analysis. When you have this time history, what has to be done is what's called a tensor transformation. So to explain on the next slide, when we do this tensor transformation, what has to happen is we're interested in the stresses on the surface of the part. Because in reality, cracks are always going to form on the surface, but internally. So we have to convert our FE results from per element stress strain to a surface stress strain. And then the other thing that has to be done is calculating this maximum damage direction. And just to clarify one thing before we keep moving on, this is all really handled behind the scenes for you. It's just helpful to understand what some of the options are telling the software to do. So we have to calculate this maximum damage direction. So essentially, if we think about this little node here, doesn't know which direction are the principal stresses. So it has to basically check all of them. Basically do a sweep over 180 degrees to see, okay, this vector is where my peak damage is coming from based on the stress time history. So we can kind of see all of these increments or steps, basically checking, is this my maximum damage direction? No, move on to the next one. And it's going to basically do this sweep, find this highlighted red vector. Yeah, and then so we can do this fatigue analysis. I can jump back to the software and show you where the output for this is. Now we can see, okay, what is happening with this input frequency, and where should I be concerned with, where damage is